All right, so here we go with the key from 6.1, and we have, let's see, tell whether each polygon is regular or irregular. So we'll do that first. So regular, of course, we know means it's equal angular and equilateral. So it has all the angles are the same and all the sides are the same, which it looks like in the first one, all the sides are marked the same, all the angles are marked the same. So this would be regular. I'm gonna use a different color. But regardless, it is regular. All right, the next one we have, well, right away we see two different side lengths, and they don't account for these angles, and there's reflex angles in the middle. But either way, we know that this is irregular. And then we go down here. All the sides are the same. These two angles are the same, and these opposite angles are the same. But because all the angles aren't the same, this is also irregular. All right. And then we're checking to see if it's concave or convex. If it is regular, we know it's going to be convex. But just to test if it is convex, if you take any 2 points and you connect them, it wouldn't go outside the figure. In other words, the diagonals would not go outside. Unlike this one, where if I connect these two vertices on the top, and I sort of go through it there, you can see that it would be concave. And not only that, but there's sort of a cave right there, right? It's sort of indented. It's concaved in. Okay. And let me see if I can get some settings here real quick. No, we're going to wing it for this one. All right. But either way. All right. So we got, and then we're checking here. We'll tell whether it's convex or concave. The only diagonals are here and here. So those are inside the figure. So this is also convex. And so if it's not regular, it's going to be irregular. If it's not concave, with a cave in it, it's going to be convex. And of course, if we wanted to name these, this of course would be a triangle. This would be 2, 4, 6. That would be a hexagon, and that would be a quadrilateral, named by its number of sides. All right, so we got find the measure of each interior angle of this pentagon. And so the thing that we know about this is a pentagon. And because it's a pentagon, we can find out that all the interior angles are going to be, 180 times n minus 2, with n in this case being 5, right? Because pentagon means n equals 5. So we get, we know 540. 540 is what all these angles add up to, right? We know that they're all going to be 540. So I can do essentially all the angles, right? So 3z plus 4z plus 5z plus 3z plus 5z equals 540. And so if we know 540, right, we get, let's add these up. We got 6, 10, 15, 20. I think that's it. 20? No. 10. 6, yeah, 20. 20z equals 540. And then we divide by 20. Oops. Divide both sides by 20 is what I meant, but z equals, well, z clearly, oops, that's not right. So z equals, we're dividing by 20, we get 27. So if z is 27, it says find the measure of each interior angle, so I just have to go back and plug this in. I hope I did that math right. But we get 108 for this one. We get 5z, which would be 135. So here and here, 135. And then 3z would be 81 degrees for each of these. So those are all your angles based on that z. Okay, so now we got find the measure of each interior angle of a regular dodecagon. Find the measure of each interior angle. Well, we can find each because it's regular. So we know that all the angles are the same. So the first thing we need to do is figure out what all the interior angles add up to of a dodecagon. And dodecagon means n equals 12, right? Dodecagon, n is 12. So we get 180 times 12 minus 2. And so we get 180 times 10, which we know is 1800. And so those are what all the interior angles add up to. And well, if we have 1800 is what all of them add up to, all we have to do is split it evenly among 12 different angles, because there's 12 sides, 12 angles. So if we split it evenly among 12, and we can do that because all the angles are the same, then we're going to get our answer here. I should have had a calculator ready for things like this, but I'm going to grab one. So pause. So we get 150. 150 is what, I could have probably done that. But anyway, so 150 is what each interior angle. Again, if there's 12 of those interior angles, that's good. And you can double check this, because if the interior angle is 150, the exterior angle is going to be 30, and 30 times 12 is going to be 360. So it all does work, but that's the answer we're looking for in this case was our 150. Okay, so it says find the sum of the interior angle measures of a convex 20gon. In other words, 20 sides, so 20gon means n equals 20, and we're just trying to find the sum of the interior angles. I don't care what each one is. In fact, I couldn't find that even if I wanted to. I'm just going to switch colors so we can differentiate between the problems easier. But so n equals 20. Okay, so we know that it's going to be 180 times 20, which is our n, minus 2. So we get 180 times 18, which is 3240. So we know that 3,240 degrees is what all the interior angles of this convex 20gon would add up to. It says find the value of y in polygon JKLM. And if I look here, we see that this is 1, 2, 3, 4. 4 sides here, so it's a quadrilateral. So we know that that's going to be 360. Hopefully you know that one by now. We know that the interior angles add to 360, but these are all exterior angles. So we know that 1, 2, 3, 4 exterior angles are going to add up to 360 as well. In fact, any polygon is going to be 360. So in this case, we just have 4y plus 2y plus 6y plus 4y, and then we set that equal to 360. And so that's just going to be 16y equals 360. And so we get 360 divided by 16, which is 22.5. So each of the y is going to be 22.5. It doesn't ask me to find the angle, so I wouldn't need to plug it back in necessarily. But there you go. I'll put an arrow there so we see what we got. And again, I should have been switching colors, but I didn't. Find the measure of each exterior angle of a regular pentagon. Well, exterior angles we know are 360. So whenever I see exterior angles, I'm thinking, okay, they add to 360. When I'm thinking pentagon, I'm thinking n equals 5. So there's 5 angles, 5 sides. So I just take 360 and chop it evenly because it's regular. I can just say 360 divided by 5, and I would get, these are exterior angles, we get 72 degrees. Right? I'm going to double check that, but I'm pretty sure there. Yeah, we good. All right, so 72 degrees is what every exterior angle in a regular pentagon is going to be. All right, so we're going to use this cool sign over here. And we got use the photograph traffic sign. Okay, so name the polygon by its number of sides. So we got 1, 2, 3, 4, 5. So we got pentagon. All right, then we got in the polygon, it says that angle P, T, and R are all right angles. And it says, so what? And it says that these two are the same. So what do we got? Okay, well, we're trying to find these two angles. So I'm going to put X by them. Now, we remember that this is a pentagon. So we did the math up above, but basically it's 180 times n. In this case, we know that this is a pentagon. So n equals 5. So 180 times 5 minus 2 gives me 540. Right? So 540 is what the total of all these are going to be. Now, at this point, just add them up. We have 90 plus 90 plus 90, which is actually 270. And we have 2x's. So we have 2x plus 90. And again, I could have added them up individually, but I just grouped them already. So 2x plus 90 equals 540. So I get, 2x plus 270 is what I meant. 270 equals 540. So 2x equals 270 when I subtract from both sides. We get x equals 135. So each of those two angles is going to be 135. So the measures of these angles are 135 apiece. And we knew they were going to be the same because they said they were congruent. So awesome. All right, so tell whether each is a polygon. If it is a polygon, name it. Okay, so this is a polygon. And we have 1, 2, 3, 4, 5, 6. So this is a hexagon. This whole figure, individually, they're polygons, but this whole figure is not. So this is, no, not a polygon. Not polygon. Okay. This is a polygon, and it is a quadrilateral. Quadrilateral. Okay, and that's all we have to name. I mean, that is concave, so we could have named it if we wanted to. It is irregular, but yeah. All right, so tell whether each polygon is regular or irregular. Tell whether it's convex or concave. All right, so in this case, again, if I connect this point to this point here, right, it's outside the figure, so I know it's going to be concave. I don't know why I did this one first this time, but whatever. And we know that it's going to be irregular if it's going to be concave, or it can't be regular, in other words. So we're going to say irregular. Now, these are tricky because all the sides are marked the same. And these angles that are marked the same, but it's these inside angles that are a doozy here that we don't. Yeah, that's a doozy. Okay. In this case, we have all congruent angles. We have all congruent sides. That looks regular to me. Not only that, but if I don't know how I'm spelling regular. So if we try to connect any of these vertices diagonally to their diagonals or using diagonals, none of them goes outside the figure. So we're looking at a convex shape. Same thing with this one. I can't draw any diagonals that go outside here. So this one is going to be convex. And it's almost regular. All the angles are congruent and most of the sides are the same, but it's these two long sides. So in this case, we're going to be done with irregular. Okay. All right, so find the measure of each interior angle of this quadrilateral. Okay, so hopefully we know that quadrilaterals add up to 360. If we don't, you know, the old 180 times n minus 2 works all the time to find out what the interior angles add up to. But in this case, we have 2n plus 6n plus 2n plus 5n. So that'd be 15n equals 360. And 360 divided by 15 is 24, so n is 24. Now, this is the only time n is not equal to the number of sides. It's just a variable. So let's just find the measure of each angle. Okay, so now that we plug them back in, we can go ahead and, again, I'll use a different color just for this. But if we plug it back in, we get this angle is going to be 48 degrees. Angle S would be, what was it, 24 times 6 is 144 degrees. Where are we? There we are. 144. This is 48 degrees as well. And then we get it's 120 degrees. So there they all are. Okay. Find the measure of each interior angle of a regular heptagon. So an heptagon is n equals 18. It is regular, so I know all the angles are congruent. I know that all the interior angles add up to 180 times n minus 2. In this case, 18 minus 2. So 180 times 16. So all the interior angles are going to add up to 2880. So again, where are we? There we are. So 2880 is what they all add up to. But again, I want to find them individually. So I will just split it evenly among the 18 angles, and which would get us 18, right? Yeah, okay. It would get 160. So 160 is what each interior angle would be. All right, so now on the next one, it says find the sum. Okay, so it's not individually. Find the sum of the interior angles. Why do I keep on losing my cursor? All right, interior angles of a heptagon. So heptagon, I'm immediately thinking n equals 7. So it's just going to be 180 times 7 minus 2, 180 times 5. Which is just going to be, of course, 900, I'm thinking. But I was right all along, it was. Take that for those who doubted me. Okay. And then we have find the measure of each exterior angle. So exterior angle, I'm thinking 360 degrees, because that's what they all add up to. Regular means they're going to be all the same. Nonagon is n equals 9. Right. So these are sort of the key words to think about when you're going through them. And so we know that if there are 9 angles and they all add up to 360 and they're all the same, I can just say, you know what, 360 split 9 ways gives me what each one can be. And of course, that's just 40. So we get 40 there is each exterior angle of a regular nonagon. Again, if it's regular, we can split it evenly. Exterior angles add up to 360 always. Nonagon is your 9. All right. All right, so here we go. We got a pentagon has these exterior angle measures. Find the value of A. So if they're exterior angles, we know exterior angles add to 360. So there's no calculation. The fact that it's a pentagon is okay, but it doesn't really help us with it. Doesn't change the fact that it's 360. And so all of these together, we can just say this plus this plus this plus this plus that equals 360. So let's see, we got 9, 20, 30A, I think. So we got 360 equals 30A. And so A is just going to be, let's say find the value of A. Yeah, so A is just going to be, well, I don't know. Let's say 360. Oops. It's just going to be 12, which is what it asked for. All right, now we're looking at this diagram over here, and it says it forms a regular hexagon, so n equals 6 is hexagon. So if we want to find each interior angle, because again, what I'm looking for is JKM, which is this, which I hopefully realize is an interior angle along with all these other ones. Those are interior angles, they're all going to be the same. So we just do 180 times 6 minus 2 to get what the total is, which is 720. And then once I have that, I can split it 6 ways because each of those angles will be the same. So we get 120. So 120 degrees. And again, I don't just draw it there, draw it on the actual angle on the diagram. And hopefully then it becomes pretty easy to see that the other angle that they want is MKL, which is this exterior angle. Now I could do 360 divided by 6 and get 60, or I could just take the 120 and subtract from 180. So, I'll write both down. So 360 divided by 6, or 180 minus the 120, but either way, they're both going to be 60, right? So that's going to be our value there. Okay, awesome job, probably. Okay, these involve a little space. Should have given you more space. Why does anyone complain about that? Oh, wait, you do. Okay, so first of all, we know this is a quadrilateral, and quadrilaterals added to 360. And so all of these basically add up to 360. So if I just sort of simplify a little bit, we know we have two x's here. We have 110, 130. So we have 240, and we're subtracting 3. So we have 240, so 237. So I just combine the like terms, and we know that that's going to equal 360. So when I do 360 minus 237, and then I divide by 2, we get x is 61.5. So I'll just write it up here. X equals 61.5. All right, in this case, we have a hexagon, 1, 2, 3, 4, 5, 6. This is a hexagon, so we know that all the angles in a hexagon add up to 180 times 6 minus 2, which is just going to be 720. So that's my equation I can write. I can say x plus x plus x plus x. So we have 4 x's. We have 90, 90, 22, and 22. So we have 180 plus 22. Oh, no, 2 times 20, so 44. So we have 224. So 4x plus 224 does have to equal 720. So we subtract, and then we divide by 4. And so, oops, that's not right. 496 divided by 4 is 124. So x is 124. Not if I'm saying we should look at the diagram, but at least that makes sense, right? It's not bigger than 720 or anything, so we know that that could definitely be it. Okay, in this case, this is a 1, 2, 3, 4, 5. So we know that the interior angle is a pentagon. So 180 times 5 minus 2 gives me 180 times 3, which is going to give us 540. And so what we can do is define all the interior angles. Now, in this case, it's marked as equal angular, so we can just take this 540 and we can just split it, right? We can split it 5 ways, which gives me 108. So each interior angle is 108. Well, how does that help me find this one exterior angle? Well, they're just supplementary. So we can just do 180 minus 108 to get 72. So that x has to be 72 in this case. I think we're going to skip these for time right here. So we'll just, I think I said that in class as well. So I'll just write that in for now. If you did them, awesome. That's great. All right. So it says name the convex polygon whose interior angle measures have each given sum. So it's telling me that all the angles add up to this 540. Now we just did one, so we should have an idea, but we should figure out, and it says name it, so we're going to give me the number. We're going to name it based on the number of sides. So we have to find the number of sides, which means we have to find n, but I'm just saying something. I'm saying something minus 2 multiplied by 180 has to give me 540, and when I divide both sides by 180, again, I'm going to show this step on the first one, but not the rest, we end up with n minus 2 equals 3. So n, when I add 2 to both sides, n equals 5. Again, but that's not really what it's asking me for. It's asking me to name it. So if it has 5 sides, which is what n is, it has to be a pentagon. So that is definitely what it's asking for. Okay, and so now we kind of do the same thing. We know the interior angles are 180 times n minus 2. So 180 times n minus 2 is going to give me 900 because it's telling me what the sum of the interior angles are. When I divide by 900 divided by 180, I get 5. So when I divide both sides, I get 5 equals n minus 2. So n equals 7. So a 7-sided polygon is a heptagon. All right. So in this case, we get 1800 equals 180 times n minus 2. So when I divide it out, we get 10 equals n minus 2. So n equals, when I add both 2 to both sides, we get 12, which we know, a dodecagon. All right. And then in the last one, we get 2520 equals 180 times n minus 2. And so when we divide by 2520 divided by 180 is 14. So we get 14 equals n minus 2. So n equals 16. And so a 16-sided figure, we don't really know the name of it, but it is going to, but if it does say name it, we would, of course, name it by its number of sides. So it doesn't have a cool specific name, but 16gon is what we're looking for. All right, now in the next case, sort of I covered it up a little bit, but it says an exterior angle measure of a regular polygon. So we're talking about a regular polygon. I think I did both these in class, but that's okay. A regular polygon is given. Find the number of sides and its interior angle. Now, if it gives me an exterior angle, I always know that like an interior angle and an exterior angle are always going to add up to 180. So to find the missing interior angle, I can just say, you know what, 180 minus 120, and that just gives me 60. So 60 is going to be my interior angle, and I can do the same thing over here. So I'll just do those right away. 36 equals 144. Okay, so those are the interior angle, but then it also asks me for the number of sides. Well, if I know that the exterior angles are given, so when I think exterior, I think 360. I know that it's essentially 360. So it's like how many, because they're all the same, because it's regular. So how many of these 120-degree exterior angles fit into this 360? Well, if I didn't know that off the top of my head, we just do 360 divided by 120, which gives me 3. So in this case, n equals 3. So that's the number of sides it has. If it said name it, you'd obviously say triangle. I'll do the same thing over here. I know that the exterior angles add to 360. They're all 36 degrees. So how many of those 36-degree angles fit into the 360? And you'd say, okay, that's no big deal. That's just going to be 10. So once we have the, what was it, n equals 10? Yeah. So we know that the number of sides is 10. We know that the exterior angle is 140 and 60 respectively. Okay. Which term describes the figure below? Okay, so in that case, is it a quadrilateral? Yes. So we're looking at definitely a check there. Is it concave? No. Is it regular? No. So it looks like 1 only. Which statement is not true about a regular 16gon? It is convex. If it's regular, we do know that it's convex. It has 16 congruent sides. Yeah, because they're regular and it's 16gon. That is what it means. Some of the interior angles measures 2880. Well, we'd have to figure that out. 180 times 16 minus 2. So 180 times 14 is actually 2520. So that is the one that doesn't exist. I think what happened is they were counting you to not subtract 2 from that, but we're smarter than that, so we know that is incorrect. And let's just double check. It says the sum of the exterior angles, one at each vertex, is 360. We know the sum of the exterior angles is 360, so that one's definitely true. So the one that's not true is the one that we just proved. All right, now we have to draw this thing out. So polygon A, B, C, D. So I'm just going to go ahead. I know it's a quadrilateral, so I'm just going to sort of draw a blob quadrilateral here. A, B, C, D, and we know that angle A is 49, angle B is 107, C is 2 times D. So I'm going to say if C is going to be bigger, right? And D is going to be smaller. So if I said X, I'm going to make D, and so I'm going to make 2XC. So that way C is 2 times bigger than D, right? So if I take 2 times D, it gives me C, okay? So we can just think about it in that term. So it says, what is C? Well, in this case, we know that all of them together add up to 360. So we get 49 plus 107 is 156. So we get, essentially, our equation is 3x plus 156, 1. That's totally a 1. It was all along. I don't know what you're looking at. 156, and we subtract 360, and then we divide by 3, and we end up with 68. So x equals 68. All right, and so that does it. Yes. See you in the next one. Oops, forgot to box that one. I'm going to put a box around it. Bam. All right, now we're good. Oh, wait, 68 was here. I forgot to bubble it in. Okay, now I'm done.